Hi, this video is to show a little hack I made to these devices from Amazon. This is programmable voltage step-up controller or step-down controller that you can buy for 20 bucks. It has two boards. If you remove the power supply board, you can expose the little connector on the back, which has a RX data, TX data, ground, and 5 volt. The way they did this is they have the top board with display and microcontroller talking to a power supply board via MODBUS. There's a microcontroller here on a power supply board. So I figured out that you can actually use the Modbus to control the power board itself using computer and simple USB to RS-232 interface and TTL to RS-232 module. I wrote a little LabVIEW application based on, based on RF Porter MODBUS master, and I took one of their VIs and just slightly modified to fit my application. This board is made by these guys, Woozy International, whatever. I tried to contact them. They asked to ask about this device, but they didn't respond. But I did manage to find some documentation for some of their different model of the power supply, and they actually did publish the Modbus library, and apparently this library works with this module too. So you can see the LabVIEW application is controlling this by sending a request to a device, this yellow trace here. Let's zoom into that guy. I'm sending the request basically to read about 30 registers, and then in the blue line here the device is spitting out 30 registers, and I'm parsing the data, whatever it's on that data sheet. So you can set voltage, for example 3.3 volt. Let me zoom in, and unit response with 3.3 volt. I set half amp current limit. This is bottom field is a measurement of a voltage and a current and a state of the device. So I can turn on some load, for example 200 milliamp, and device measures about 200 milliamp of current at 3.3 volt. If I increase the current beyond half amp, this will go in constant current mode. So if I go to 0.6 amp, the device switches to constant current mode and voltage goes down to almost zero. If I go back to 200 milliamp, it recovers and goes back. So this device cost about $22, and you can remove this module and make a little programmable power supply to use for some other projects. That's it.